Hi, everyone, and welcome on board. We are today on the third episode of Global AI Notes, and we are having a very special speaker today, Beth Pan, who will be giving us an amazing overview and walkthrough on Windows AI. So let's get this rolling. Hi everyone, I'm Zaid Zaim. I'm a Microsoft MVP for M365, and I'm glad to be today your host here. And we have a very special guest today, Beth Pan, joining us all the way from Seattle, who will be sharing all things around Windows AI. So welcome on board, Beth. Please, would you like to cheer the community, introduce yourself, tell us a little bit about the cool stuff you do.
Okay, so my name is Beth. I am a software engineer working for Microsoft, specifically in the Windows org. My team, I think it's called the Windows Platform and Developers now overall. Anyways, we build cool things from developer platform to underlining APIs and frameworks to help developers build on and for Windows, including things like productivity tools, client platform. If you know some people on my team, we also host things like the Windows community calls, try and engage with our MVPs, just like you said as well. So that's kind of what I do. So my goal is to get more people to use Windows as much as possible as developers. And today we're talking about only like one little aspect of it, I guess, is AI.
Amazing. Just like a small energizer, perhaps, before we start with your talk. So, let's say for very new people in our audience, what is Microsoft Copilot plus PC?
Wow, that's a hard definition to give. So first of all, it's a Windows operating system PC, spanning different OEM partners, including our own service machines. I think the one key factor to consider for Copilot Plus PCs is it has all those powerful NPUs that will allow you to run machine learning models and AI solutions more efficiently because it's accelerated by the hardware.
Mm-hmm. Nice, amazing. So let's. So I think how this today will work. So we will have an inspirational talk provided by Beth, and throughout the talk, we will gather questions from the audience, and either I might be asking you some questions, Beth,
cool.
Or we can take a couple of questions just after the presentation. Thank you for being here, and looking forward.
Sounds good. Please keep the questions coming. I feel like it's more interesting to have like an interactive experience versus just me talking, especially virtually. It's always weird that there's no like your audience's reaction.
Totally, yeah.
Anyways, today we're going to talk about infuse AI in your Windows apps. I already kind of introduced myself, software engineer at Microsoft. For those of you who are cool kids on Twitter, you can follow me at Beth Pan. Maybe not so cool on Twitter anymore, or is it called X these days? And there's other things that people do. I don't know. I'm in my little world still on the X platform. Okay. So on-device AI, what is it? It's also called, local AI, edge AI, many different names. It mostly refers to artificial intelligence models and computations that run directly on a device. And you can think of things like your laptop, smartphones. Sometimes we're talking about IoT hardware as well. These kind of devices does not need to rely on cloud-based servers for processing, which is why we call it on-device AI. And then, so this approach leverages the device's own hardware to perform tasks like things like image recognition, natural language processing, real-time decision-making locally, rather than sending data back and forth remotely to the cloud to process. So a couple of things, I think, when we talk about local AI, why you should consider using it, or like why is it important, right? I think these are some of the things that I can think of, certainly not limited to these things. There's more than just what we listed on the screen here. So you can think about things like running AI models locally would allow sensitive data to stay on your device rather than being transmitted to the cloud. So this would help you enhance privacy, reduces, the risks of breaching anything, and help comply with protection regulations like GDPR. Secondly, local AI eliminates the needs for network communication, which leads to slightly faster, or in some cases, if you're using older devices, a lot faster processing time. So this is especially important for real-time processing applications like voice assistants. If you think computer vision, gaming, like what immediate feedback is crucial. And then when you're running AI models locally, it kind of reduces the reliance on cloud infrastructure. So when you're developing, especially during the development process and in deployment to your users' hardware, if you're not relying on the cloud infrastructure, then it's less costly and reduces this like heavy or frequent usage on the cloud. So your user can also avoid cloud computing costs and dependencies on internet bandwidth. This is not to say like cloud computing is not important. There are certain use cases that we see that's more useful for on-device AI. There are more cases that's certainly client to cloud from a deployment perspective, depending on how you would like to scale your applications. Last but not least, local AI allows apps to function without an internet connection. So this will be valuable for users. You can consider in areas that doesn't have reliable internet access, or the devices that are designed to work in remote environments. I remember when I used to work for this insurance company, we are very gated for data can't leave the device when the agents are actually out working with customers, they can't have their devices to be online. So a lot of times I can imagine offline functionalities would be useful for developers to consider. There are other things like customization and controls and like sustainability, but I think these four are something that came to mind when you think about local AI these days. So we keep talking about AI, and all of a sudden this whole like NPU on-device AI, local AI became a topic. And I just want to touch briefly why we're all like quote unquote all of a sudden talking about it now, right? Because I feel like AI has been around for a long time. We have a lot of ML developers, machine learning developers building these models, researchers trying to define how models work, developers trying to utilizing these models. All of a sudden we're saying, now it's ready for on-device. Why? So first of all, it's because the advances in hardware, we're seeing more and more powerful devices with things like tensor processing units and NVIDIA's GPUs. These chips are optimized for running AI tasks today, and it would enable our developers and users for real-time processing on these local devices. And we also, with the technology advancing, there's more and more optimization techniques that would help model to be able to run on these hardware devices and AI like specialty chips with more efficient architectures and things like Onyx runtime or Onyx as a standard format for these to become available. And thirdly, because of the research in, the past decade, these AI algorithms has become smaller and smaller, more and more efficient. We can actually load these onto these devices that we just talked about now. And last but not least, we're having more of a grown out ecosystem, such as yourself, building out the communities, enabling our developers to do more with edge AI software and the ecosystem and toolkits and libraries. So what does this translate into the Microsoft ecosystem? You were just asking me this. Like I said, there's so many great things about Copilot plus PC, but to define it, I think first, in my mind, I think of NPUs, right? We've recently announced all these Copilot plus PCs. I'm actually on one right now presenting. This is the Surface Copilot plus PC with an NPU on it that's capable of running these complex AI models as part of the advances in hardware. Microsoft has Onyx, which is like a standard to enable developers to convert these large AI models into formats optimized for running on device, and then together with things like Olive that would optimize specifically for Windows hardwares through techniques like quantization or like pruning, etc. And then we also have, Microsoft Research-backed models like 5.3 family that are today efficient enough to run on these hardware and the techniques that we were just talking about. And then lastly, with Onyx Runtime enabling developers to run AI models on devices with efficient inference, as well as things like DML APIs that will allow us to deploy models and run models across all of the hardware spanning Microsoft family.
I have a small question, Beth. So
Sure.
during build, or I think just before build, we saw this really cool announcement by Satya presenting the Copilot Plus PC combined with Minecraft. So the user is like sharing the screen, I think, with Copilot, and then it's helping you to craft something in Minecraft. So how does it actually work? So can I, like, in the future really instantly like ask Copilot to help me solve any problem I have on my Windows PC, or because it's like capturing, let's say, the history of my engagements on the laptop? Or can it be if I'm working on a, let's say, a special software like Visual Studio or something, can Windows AI also help me solving like certain challenges and stuff?
Yeah.
So
I think with the Copilot Plus PC, there's certainly a lot of different scenarios that we're considering. I'm actually getting to that. We can show
oh,
you
nice.
some inbox experiences. Minecraft was definitely one of the demos. I don't know if I remember this correctly. It was like asking Minecraft through voice to text, maybe translation, and then grabbing
Yeah.
something on screen, maybe using OCR, and then saying like, "Here's how I would build things." And I actually have some demo that would be
Wow.
not as cool as that, but maybe similar to it. We can show our developers
Nice.
how
Please,
that looks.
let's continue it. We're
Yeah.
looking.
So a lot of you might have heard of this term called Windows Copilot Runtime. I feel like it took me a long time to grasp like what this actually means, because there's just a lot of keywords in there. There's Windows, there's Copilot, and there's runtime. I don't know, it's hard to understand. First of all, it represents kind of like all these three layers together on top of our silicon. Which means, when you think about the three layers from the very surface is how users interact with applications and experiences, right? So like I said, I'm going to show you right after this slide how Copilot Plus PC enables some of these experiences out of the box. And then in the middle layer, we have Windows Copilot Library, which you might have heard of. These are like AI-backed APIs for developers to integrate. And we have, I think during build, if I recall correctly, they announced about 40 AI models that will eventually run simultaneously locally, that can power all these experiences like Studio Effect that would make me look, I don't know, kind of like animated on my screen through my camera that's built in. Things like auto super resolution that will help gaming softwares or gamers create like a more cohesive experience. Things like co-creators for Paint, or upcoming we have things like Silica or OCR and more things like that. That's the middle layer. There's a lot there to unpack. And then on the bottom layer, you may say maybe Windows is not shipping a model or an API that fits my need. What if I wanted to bring my own AI models to build my own application? What is that going to work? But we also have all these frameworks, such as I just talked about, Onyx Runtime, DML, WebNN, like Olive, AI Toolkit for Visual Studio Code that will help you make that possible. So during this presentation, if we have enough time, we'll unpack like a little bit layer by layer from applications to Copilot library on device models, all the way down to the very bottom of how to bring your own models. So we keep talking about these like applications on device. Let me just show you Paint real quick. This is
I love live demos.
very interesting. So Paint introduced these functions called, image creators, co-creators, that you can give it a kind of like a description. And then as you draw on your computer, it's going to give you like an integrated version of what the computer thinks that you're drawing, right? Yesterday, when I was practicing my demo, I wanted to draw like something like, I have a Rottweiler dog. I wanted to draw like a dog as a pilot, like flying a plane. And I was like, this is going to take over the entire presentation. Maybe I'll just do something simple. So let's say we want to draw a meadow. And I'm just gonna do a little line here and maybe add some colors. And bottom is green, and then the sky is blue. And, maybe I'll add some cloud. And you can see as I'm drawing here on the right side, co-creator is adding this
Wow.
kind of like a grassy feel on the ground, sky. This looks familiar, maybe to some
Nice. It reminds me with Windows XP
I know, right? Exactly.
background.
Maybe we'll
Yeah.
change the crayon, get like a little white, and let's see if this actually becomes a cloud. Sometimes it gives me a butterfly versus a cloud. Okay, another cloud.
Wow, this is really, really amazing.
Crazy,
Um,
right?
like personally, I like if you ask me what is your experience being an artist in quotes, I can tell you zero. But now by seeing this feature, I think I can start kickstarting
Creating.
my
Yeah, for
artistic
sure.
skills. Wow.
But what's really cool about this is if I have my task manager open here, if I drag this over here, you can see it's actually utilizing the NPU. So if let's put this on the right side, this on the left side. If I do like another cloud here, you will see a little spike coming up, showing that this process is actually using NPU doing AI-related workloads so that it frees up the CPU and the GPU to do other things that's less, machine learning intensive. So this is one of the examples. The other example that we like to show people is snipping tool. So what if I took a picture of this screen right here, bring it over to
This is running fully locally, right? So
yes, everything is local. In this new snipping tool on Copilot Plus PC, you can actually click this button where the AI is going to analyze what's on the screen, and you can grab from image to text immediately. You can see how this is going to be useful for taking a screenshot of a PDF or whatever document is on your screen, and then immediately being able to copy and paste these things, right? And we were also talking about something like super resolution or studio effect here. I keep getting those two confused. So for studio effects, it's like something that's built in with your computer. So if you're a software developer building things like a camera app or something processing video, you can see there are these APIs directly tapped into it. You can add effects to what you want the video to be processed to be.
Yeah.
Okay, so that's applications, right? Wow. These are all these great inbox applications that's already utilizing NPU on the Copilot Plus PC. But when you think expanding outside of Windows, as developers, we can also build these experiences ourselves. And today we have a lot of partners doing this work already, such as Be My Eyes is kind of like a great example of accessibility, helping people with challenges seeing colors or things clearly to understand more color-intensive charts or graph. There are also things like WhatsApp, from, I don't know if they actually have this, from like audio to text, maybe not. But imagine all the scenarios that AI can enable your software to do applications. That's the very top layer that we're talking about right here, applications and experiences. Now, after this, let's talk about, first of all, any questions? No? Okay. Moving on.
No, I'm with you.
Okay, let's talk about the Copilot, Windows Copilot library, which is not to confuse with the runtime. Runtime is all three stacked together. Libraries are only the middle layer and on-device models. I actually have a demo that is open source that you guys can take a look later. Let me bring this up here. Is this big enough?
Maybe we zoom in a little bit more. Yeah.
Is that good? Okay. Sorry. Let me bring this up. I'm just trying to rearrange my screen so I see everything all at once. So this is a note-taking demo that we've kind of showed at Build, our team put together utilizing a lot of different APIs. So let me just run this real quick so you can see what it looks like in real time. Okay, first of all, this is a WinUI 3 application, which means it runs native WinUI 3 WinApp SDK runs natively on Windows. And .NET application behind the scenes so that you can use all these NuGet packages available to you. What the Note app allows us to do is showcase a couple different things through this single application, so I don't have to pull up like 3 different demos. So first of all, remember that OCR demo that we were just talking about? Maybe I have like an image that I wanted to show, that I wanted to drag into my application as a student, that I, as I'm taking the class notes, I took a picture of the Blackboard. But then when I get back home, I wanted to like upload this picture into my class notes app and then see what's on this picture. So if I drag this picture over here and click on it, you can see like with OCR, it'll kind of understands like what's on this paper and help me copy and paste these information directly from
Wow.
the image, right?
Yeah.
And
does
then
it support like translation features as well?
Yeah, so this is image to text translation, and I'll show you the code here shortly. But it even recognizes things like handwriting, like not only things that's on the paper, but things that I wrote about office hours and what it is. So this is very cool in my opinion. Behind the scenes, what it does is,
I mean, like I'm thinking on a personal base. Personally, I love usually brainstorming with my team. So we usually like do a lot of rapid brainstorming sessions, and these like design thinking workshops. And this approach is really amazing, I think.
Right. But like I said, with OCR, WCL. What you can do is very simple in the Windows Copilot library. All you need to do is find the language model, whatever it is, or like not language model, whatever model it is. Ask the system if it's available. If it's not available, make it available. This is behind the scenes is going to download the model and make it available at runtime across all of the software that you'll be using later on. And then once this text recognizer is available, we simply call, pass it in an image, and then do some processing. Like very simple, right? Like imagine when Windows Copilot Library becomes available, all you need to do is writing like one function, 5 lines of code, and everything behind the scenes would just work.
Oh.
Right? This is what on-device model can do for you. Normally when we do this demo, I turn on the flight mode, but because I'm online presenting, I can't actually show you with like my everything locally. You're just gonna have to trust me. All of this is running locally at the moment. Everything I'm showing you today is going to be local. So this is the layer that we were just talking about right here. Right here, Windows Copilot Library and on-device models. Super simple. There are more of these coming soon, and I'll talk about the like what's coming soon here shortly after we're doing other demos. But like I said, what if one of these models among all 40, whatever it is, does not fit your need? As a developer, you wanted to bring something that's not shipped as Windows. How do you do that? Through our AI frameworks and toolchain. So switching back to this demo again. First of all, we're kind of simplizing, symbolizes like how the process of finding a model, right? Let's assume that you already know which model you want to use, and you just want to know how to use it on Windows. So I know that we're not talking about like all these amazing free locations where you can download models. Hugging Face is one of them. Onyx Models Zoo is another. GitHub has its own now, so there's a lot of places that you can kind of go. Try before you buy it, kind of like see what the model look like, play around with the data set, and then finally make a decision. So in our case, we wanted to use this model developed by OpenAI called Whisper. What it does is taking in kind of video files and then transcribing it or translated the audio into text files, which in our case, I feel like when I'm taking a class might be useful because I wanted to record like 20 minutes of what my professor is talking about, but then when I go home, I wanted to upload this audio, and then my notes app should be able to transcribe everything into text for me. So what I'm going to do here is, first of all, you need to download the model, like I said. We already have it here in this Whisper folder right here on the side. I know it's a little small. And there are different versions of Whisper models from large to small, medium, small, but tiny. The difference is the larger the model is, the more accuracy there is. But then depends on your hardware and your capability of how your app is going to be. Maybe you wanted to pick a smaller model, but with less accuracy, but accurate enough to do the tasks that you wanted it to do. So what it looks like is, if I go back to my notes-taking app, you can see that I've uploaded a MP4 here. And what Whisper is going to do is actually taking this entire 52-minute video and then like section it into different sentences, give me timestamp, and tell me like which, whatever that you want to do with this text. And when you can imagine, like, this kind of opens up more possibilities for you to do things, because once I have this text, I can do things like summarization or searching, semantic search, right? So with these texts, sometimes I want to search across all of my semester's notes and say, here's something that I want to find. So that's something that we can do here in this demo as well.
Wow.
Yeah. So you can also visualize these models before you do something with it. There's this application called Neutron. I don't know how to pronounce it. Neutron. So let's call it Neutron. All it does is it's very simple. It shows you the algorithm behind the scenes for the model, right? Like you can see the input is our audio file. It shows you like the constant, like the transpose, the slices, what have you. I'm not an ML engineer, so I don't understand all the algorithm behind the scenes. But what I do know is when you're looking at how to set up the Whisper model, what you needed to do is, first of all, we're getting this model from a model path, and we're calling an inference session. And then in the inference session, we're setting up all of these parameters. These are basically documentation that you can get from things like Hugging Face when you're downloading a model, how to set it up. And then all you need to do is simply call run this inference session, and then it's going to give me whatever that's needed as the result. I can show you a live demo here too. If I go back here, what if my classmate sent me like a WhatsApp audio that I wanted to see what it is? I can submit this. I actually don't have WhatsApp set up here, so I just copy the audio from a different computer. If I drag this over here, you can see it's processing behind the scenes live in the output window. And if I click it, it's just going to be like super fast, say like, hey, I'm going to miss the class. And my name is not Nicola. This is from my coworker, Nicola. And then I hope they're not upset with me. Like, tell me what else that I need to do with this class. So, right, very quickly, you can see like all the use cases of uploading all these audio files and translating it into something else, text format. Cool. So does that make sense?
Yeah.
Okay, cool. So like I said, once you have all this text information, maybe you wanted to do something like summarization and semantic search. And that's something that we also try to include in this demo as well. So search is a functionality that you kind of see a lot of applications do, and it's like a make it or break it for your users, right? Like if a search is great for your application, people want to use it, especially with a lot of content. If search sucks, you kind of like, that's the first thing you pick out. You're like, this search for videos or for anything doesn't work. So semantic search is a way to actually search for content, not by the content itself, but by its meaning. So to do this, we're going to use something like the embeddings models right here in the Onyx models again, that we downloaded from Hugging Face again. And if I go to the embeddings.cs, you can see the models that I'm actually using is called blah. And similarly, just like Whisper, I needed to set this up based on the documentation, adding all its parameters. And pretty simple. This is giving me like information, explaining how it allows us to actually convert content from something that we can map into like a multi-dimensional space. And embeddings is essentially like a multi-dimensional vector that we can represent in like multi-dimensional spaces. In our case, this one, I think it was like 380 something dimensions, just a couple more than we're used to. So what I'm going to do is I can actually go into the semantic search file, set up some breakpoints to show you how this looks like. So if I go to this line, I can set up a breakpoint here in my Notes app. If I search for, let's search for how many parameters of, oh, I'm not done typing, but that's okay. It's typing a little slower. Continue. Can a function take? So you can see once I stop typing, it goes up to this search vectors function. If I step into it a little bit, into the next line, then you can see all of a sudden this vector shows me all of the floats, like I said, represented in dimensions, 384 of them. And if you open them up, these are just training data that gives me like kind of like a distance in the dimensions, like how far these vectors are actually to each other, so that we know like what the meaning is behind it. But what it does in the application is, let me continue. Instead of searching for the exact text of how many parameters can a function take, it actually found the meaning of this search query and said a function can take in as input 0 or more inputs, which means our algorithm actually understood what I was asking. And instead of searching that string, it sought after throughout this course and found like what the actual results for this meaning is. So now we have all these like stored vectors, and we have our new vectors that we, vectorized. We can find the distance between, like I said, between these vectors, and we use this function called, this is like a .NET function, cosine similarity, in order to like find the actual meanings behind it. And if we continue this, we just got back to what we found. It's very easy to build out these like experiences, in your application for users to ask questions and find what they need to find like fast. Okay. Like I said, semantic search is important, but then once we have the text, there's also a lot of other things that we can do, such as, text summarization or autocomplete, or reasoning over all this text that we have, right? So this is something that we're using as, it's called 5.3. Like I said, this is a Microsoft research-backed model that's been in development for a while, and it's very popular these days. I don't know how many of you have heard about this or used it before. There's like a whole cookbook, I think, about different versions of 5.3 and how to use them. And our cloud team is, I think, very involved in this work as well. And if you look at how this works in code, we're using this library called Onyx Runtime Generate AI. So if you go to my dependencies, NuGet package, like I said, you can see all these NuGet packages that we're using to utilize Onyx Runtime extensions, and to actually use Phi. All you need to include is this Microsoft ML Onyx Runtime Gen AI. We're using the DML version of this whole thing. And so what this API gives you is a very easy and flexible way to run language models, large language models, small language models in this case. And we can call like a very high level generate method or run each iteration of this model in order to find like what to do with the text that we have. So for example, in my Notes app, I can go into a lecture and say, let me copy all of this and right click. I can try to summarize it. And behind the scenes, the AI is going to take a look at the content that I just copied and try to give me a summarization of a couple like pointers here in my notes right here. So I don't have to actually read through the entire class now in order to understand what my professor talked to me about for like an hour. Maybe I just skip class today. If you know me in college, I skipped as many classes as possible. I always borrow notes from my classmates. So this would be a very useful function for me. Again, behind the scenes, sorry, were you going to ask something?
No, I just like one question just came to my mind. Basically, how does Windows AI intersect with other Microsoft productivity tools? Does it
Like
have like
when
Teams or so?
okay. I think right now we're trying to work closely to expose what's on the system for things like Office and M365 to tap into. I'm not sure if there's any like very like visible correlations between these things. Well, you can see like Copilot is kind of like a concept that's embedded in all the services and product that we have, but it's also scoped down to the environment that you have, right? Like Windows Copilot's not Windows Copilot anymore, but the idea of Copilot on Windows is that the artificial intelligence is aware of your OS system, like what you're working on, kind of like understand your app and your environment and give you like contextual recommendations. Same as when you're using Copilot in Word, right? Like if you are working within your document, then the Copilot is only like gated within your document and then understand what that data sensitivity looks like. And if you use it on Edge, that's like more of let's look at the web and see what's out there and what we can make suggestions. So I think there's definitely a lot of like data privacy and trust involved in our like different systems of how Copilot evolved from different platforms. For Windows, I feel like there's definitely going to be more and more on-device models that's going to be available for first-party apps to tap into once the Windows Copilot library becomes more available, like readily available for developers. But yeah, I think this is an exciting time that we're all kind of in. There's a lot of things that's up and coming. There's things that's developing very fast, rapidly. And if you keep up with the news, you will see how rapidly changing these are. Like DML used to support GPUs across the board. Now we're 2 weeks ago, we just introduced all these models that's actually runs on NPU. And because, you know, it's a more close to like more for like native developers. So like C++ is always available first, and then you can imagine like things coming up next, like C# or WebNN or things that evolve like across the board. So I think remember to always learning is something that our industry is hopefully people are.
Yeah. Yeah, and I think like coming up, there's let's say the season 2 of Microsoft AI Tour.
Yeah.
Is there anything specific we can look forward to for within the Microsoft AI Tour in context of Windows AI?
This is a great question. If this is going to my leadership, they're going to think that I seated you with this question, but I actually we've been working very closely with our partners across the company to figure out what does the Windows AI story going to look like. And yes, we do offer a theater session. It's very short, I think 15 minutes in each location, because each location is only a day, right?
Yeah.
We have like a 15-minute theater session that we're gonna kind of like condense down what I'm showing you here to 15 minutes of what does Copilot runtime mean and how does everything work.
Amazing. Yeah, like I was literally mind blown with the paint demo that you showed. Like I am very bad in drawing, so I have zero artistic skills, and this is like really I like nowadays for generating like banners, pictures, you name it, I always rely on Copilot or DALL-E to generate things. But now I think I have a new good friend Hey, to start playing around with.
Do something more. Yeah.
Yeah.
I think we have only maybe 10 more minutes. I'm not going to show any more code anymore. Maybe we'll just wrap up the notes sample and then do a recap. Does that work?
Yeah. Amazing. Perfect.
Okay. So last thing I kind of want to talk about, like I said, I'm not going to go back to code anymore, but just to show you this is running in real time, there's this concept called RAG, where, you know, when you're combining different models together, you can do things that's reasoning over the content of your own kind of environment. So if I were to run my semantic search with the language model that I just introduced, then I can use the language model to help me find information specifically to my application. And this is the pattern called RAG, right? Which is also retrieval augmented generation. So things like if I go to this little robot and said something like, when is office hour? So you can imagine if I were to search this, continue. If I were to search this with any language model, it's going to go out to the internet and find like when it's office hour for me. But in my situation, it should actually go through my content, which it finds the lecture in lecture 2 and then found when the office hour is going to be. So like I said, this is like when you combine multiple models, there's a lot of cool things that you can do. And today we've showed you like how to use Phi as a language model, how to use embeddings for semantic search, how do you translate Whisper, an open source model, into the Onyx format in order to do audio to text transformation, and then how to combine two of these models to do like retrieval augmented generation. Okay. Let me stop my app so that you can see the rest of the presentation.
Yep.
Okay, let's do a quick recap for what we've talked about. First of all, we talked about the Windows Copilot library. Right here, you can see in the middle section. Specifically, we use the text recognition APIs. Phi is coming soon. We also have things like vector embeddings, RAG, text summarization also coming soon, which means you don't have to write all of those code that I showed you in order to invoke those. All you need is 5 lines. Ask if the model is available, download it, invoke it, give it a prompt, and then it's going to generate whatever you need giving back to you. This is going to make developers' life so much more easier. Just, you know, within seconds. I can't wait for Copilot library to become a reality so that we can tap into more AI-backed APIs behind the scenes.
Yeah.
But when you bring your own model, like we showed you at some of the Notes app, this is when you get to the actual APIs and frameworks. And DML is a single hardware abstraction API that allows you to optimize and deploy models across like everything Windows has. And whether it's running on, you know, Intel or NVIDIA GPUs, or we're working to include NPUs as well. It also supports 4-bit AWQ quantization so that you can make your models as small as possible and then still maintain accuracy. And this is available today. It's actually available for a while now. You can use it as a NuGet package, including in your .NET and C# application. Couple important concepts that we do have to touch on is the Onyx family, right? So Onyx is just a format. Onyx runtime is the runtime that runs the format, and fast and efficiently, very high performant. ORT generate API is the API, the NuGet packages that we use specific to language models in generative AI models. And then Olive is what we use to actually transform Whisper model that's not on an Onyx format into Onyx format in order to make this application available. There's also this cool thing called AI Toolkit for Visual Studio Code, which if you're interested, you should definitely check it out. You can download the models and try them out directly within Visual Studio Code, and you can also fine-tune, optimize these models using Olive, but not through the command line because it's wrapped very nicely in this UI environment. And then finally, you can also deploy your application model either on client or on the cloud. Okay, if you need any of this information, what we just talked about, go to aka.ms/WCR so that you can have all of the information and ask any questions.
Nice, amazing. I loved the conversation today, and it was yeah, really cool deep dive for me also personally, and to the audience. Yeah, about Windows AI, like the only yeah, very very inspiring, especially the like the paint tool. Yeah,
Next,
yeah.
I, I guess our
Sorry.
next time I'll just show the paint tool the whole time.
Oh yeah. Nice. So is there any call to action you would like to share with the audience? Is there any special resources you'd like to drop in the yeah to share with us or
I think just stay curious. That's the best advice that I have. And then, like I said, oh, that's the wrong link. WCR is actually the link. Check out this link. WCR. I dropped in a private chat since I have to sign
amazing?
in to comment. So
Yeah,
for everyone who wants to get more information.
great, great. And like one thing we can definitely be hyped on is the Microsoft AI tour coming up very soon, or I think it's already ongoing. So yeah, incredibly looking forward to this, and thank you very much for joining us today. It was very nice conversation with you, and we learned a lot. Yeah, and let's stay hyped on Windows AI, and looking forward to what's coming up. Thank you
Cool.
very much for joining us.